Hello everyone, welcome back. So in this video, we are going to understand another question Q2 from the contest 465. The question is balanced K-factor decompositions. Means we have given two things. Very first is n we have given and k. These are two integers. As you can see, n we have given is 100 and k equal to 2. And it is saying that split the number n into exactly k. Means we have to split this number into k in such a way their product of these numbers is equal to what? If we'll split in how many ways? In two ways, right? We have to split into k positive integers. Let's suppose 100 and 100. 10 and 10. If you multiply 10 and 10, it will give you 100. That is what the question is saying, that we have to return any number of a split which is maximize the difference between any two number is minimized, right? It means we must split the integer n, right, in k exactly k positive integers factor whose product will give you the result, okay, n, which is equal to n. And among all such a split, we have to return any split that minimize the difference between the largest and the smallest one, right? We can say the max minus mean as small as possible. Understand? Means we have to minimize. What we have to minimize? The difference between the largest and the smallest factor. If we have the factor max and mean, we'll just do max minus mean. This will become as small as possible. If it become as small as possible, if max minus mean, that is the result we have to provide, right? So order of the numbers in the return doesn't matters here, but we have to focus that very important is there, like every number in the split must be a factor of n, we can say, okay. It should be the number that we are going to split, it should be the divisor, right? Like 10 is the divisor, right, of n, we can say, and the product of their k numbers, if you multiply, it should be equal to n. That is, we need to do that, okay. Very first, try to understand the question and then apply the things. Let's talk about this example, okay. So here we have given n equal to 44, we have given k equal to 33, right? So if we will find the all the divisor of 44, right, what are the divisors are there? We'll say 1, 2, 4, 11 and 22 and itself 44. Can we say that? So we need the triplets a, b and c, right? So if we need the triplets, we just need to do what? A into b into c, and that will give you the result 44, right? So some possibilities are there. If we'll take, let me tell you how. So because I'm going to explain this one because it's very important to understand, okay. Very first, n we have given is what? 44 we have given, right? And if we want the divisor, what are the divisor are there, right? So divisor, we can say we have 1, we have 2, we have 4, we have 11, yeah, then we can take 22 and 44, right? These are the divisors we have, right? And if we want the triplets, you know the triplets is combination of three letters, right? We can say we need a triplets, let's call a, b and c, combination of 3 pairs, and with we can say that gives you a into b into c should be equal to 44. Can we see that? We have to, let's list out some few possibilities which is non-decreasing order, right? Let's call if we'll take 1, triplet 1 and 44. Can we say that? If we multiply all of these, we'll get the 44. And if we want to find the difference, how we're going to find the difference? In this case, let's suppose difference, if we'll find, let's call 44 minus 1, we'll get 43. Now let's take another triplet 1, 2 and 22, right? In this case, the difference will become what? We'll say 22 minus 1. Max is 22, mean is 1, right? And we'll get 21. Again, we'll find another triplet 1, 4 and 11 we can take, right? 11 into 4 is 44. Then if we find the difference will become what? 11 minus 4, not 4, is 1 is equal to how many it will come? 11 minus 1 is 10, right? Okay. Another triplet find 2, 2 and 11. If you find the difference, you will get what? Here we will get 11 minus 2, max minus mean is 9, right? And similarly, if you find anything else, it's fine. If you take 1, 11 and 4, it will be same as 1, 4 and 11. So for now we'll leave others, right? That is, this is the sorted one, this is not sorted one, right? But the result will come same. So all of this, if you see, this value is the best among these because we need the mean. If you know the max minus mean, right, and what is coming, it should be as small as possible, as I told you, right? So 9 is the smallest one among these, right? So this is the best answer among all of the here. Okay, and so the minimum difference is 9, we can say, that produces the result, and this is what we have the answer. As you can see, this is what we have here. I hope you understand. If you have any doubt, please ping me in the comment box till now. So what we will do, we'll use a pointer and DFS, right? Because we need to do. So we'll run the DFS and we will do the backtracking that will pick the divisor, right? Once we file the divisor in non-decreasing order to avoid the duplicates that we have seen here, right? So it will make easy pruning, we can say that. Okay, so we'll use a divisor array, right? Let's call like this, and we'll need some factor of elements. Let's suppose call a k equal to 3, right? Because k is a triplets, so we need this one. Okay, so we want k equal to 3 factors, and for that what we need to do, we'll take the, let's call remaining, right? We'll say how many left is there, right? We can say we'll start at where, let's suppose 44, and we'll take a k left, and there will be some path will be there, right? So path will keep adding onto the path. So 3 things we'll take. Let's suppose we'll take the very first is, we'll pick the first element. We'll take, okay, 44. Let's start with the 44, and k left is 2. Like that, we'll keep moving ahead. I'll show you the code, then you'll understand. Give me 1 second. Okay, yeah. So we know that we have given n, we have given, and k we have given, right? And we need to do the DFS. Okay, so if we need to do the DFS, so we have to find the best split, right? So we'll take the values and we'll try over the we'll take a remaining. We will need the k and the current, we can say, right? And this is our start. Okay, so what we will do, we'll start with a k equal to 1, right? And we'll find the last factor that must be remaining. So we'll keep adding remaining into a list, right? How many is remaining we have, and we'll find the difference. So we have the max we have and mean we have. We can find from the max and mean from the current, and then you will get the difference. If difference is less than the best difference, we'll update the best difference, right? As we know, we can use a variable best difference. That is why it will keep updated. So each time when you find the best difference, it will get updated. Otherwise, we'll do the best split like this, current stream map to int, and it will convert into the array. Okay, so it will have the best split there. And finally, you will remove one element at a time, right, from the current size, and once it is done, we'll return. Otherwise, we'll try all the divisor. We'll take the divisor, we'll start from d, and we'll keep multiplying d into d, right? So d into d should be less than the remaining. So remaining will take how? Remaining will do the mode. If it is coming 0, we'll take the divisor and we'll add into the current. So all, let's suppose we have for 44, we have taken all the divisor, right? So all divisor will be added onto the current. Okay, and we'll do the same thing. We'll do the DFS again, and to find the next divisor, we can say that. And that is what we are doing here. So that's all I have in this video, guys. Let me know in the comment section that you understood or not. But if you talk about the intuition, right? What is intuition? We must use divisor of n elements, right? So we are getting the divisor here. We're trying to find the divisor. Then we have to minimize max minus mean, right? So we know that if we'll do, we have to find the minimize, and for that we have to find what? Max minus mean, and we'll try to make the factor as equal balance as possible. And then once the balance factor arises by distributing some prime factor across the k parts, so that each part is a numeric value is close to the others, and so we can say k is less than equal to 5, and the element will be in the what was that given, was it was given in 10 to the power 5, we can say that. Okay, so if we'll do the enumerating divisor based factorization with some pruning, we can say, so it will be efficient in the practice, we can say. Okay, so the key idea is to implement, we will pre-compute all the divisor, we'll keep adding all the divisor onto the current, and for the element n, and we'll sort them, right? We need to do the sorting, so we'll sort them, right? Once we have all the divisor, we'll use the DFS, right? So once you will do the DFS, right, so what will happen, we'll do the backtrack to pick k-1 divisors in non-decreasing order, we can say. So the last factor is the first to be remaining, right? So we have to we will say the last factor is nothing but remaining. And then what we need to do, when a path is complete, we'll compute the difference, as we know that, right? Each time we'll compute the difference and we'll keep the best result, and to get the best result, we'll use another variable, we'll store the best result if we'll find the best result. Okay, and we'll use the pruning to keep non-decreasing picks, so the current minimum is the best picked ever, right? So we can say we'll use we can also say, if the current contains if the current max minus means already is there in the best difference, we can skip the deeper search down that branch. Okay, so that's all I have in this video, guys. Let me know in the comment section that you understood or not, and I'll see you in the next one. Thank you for watching this video.